All right, lastly, combined gas law. Combined gas law is simply, like the name, is a combination of the gas laws that we've learned so far. And it deals with pressure, volume, and temperature. And you use this law when multiple things are changing, not just two factors, like three factors are changing, right? So the relationship is pressure times volume divided by temperature is equal to a constant. So therefore, P2 V2 over T2 is equal to P1 V1 over T1. Okay, that's the combined gas law. So to do these kind of problems, it's just like the other ones. You just have to find the facts, take out the variables that we do know. So let's read it. It says a 25 ml bubble. Okay, so we know that one of the volume is 25 ml. And it is at 4 atmospheres, so we know that the pressure is at 4 atmospheres. And we know that temperature is 11 degrees Celsius. Temperature is 11 degrees Celsius, which is 284 kelvins, right? Now, once it reaches the ocean surface, becomes 1 atmosphere. So we know that P2 is 1.00 atmospheres. And it is now 18 degrees Celsius. Forgot, this is a T1 over here. So our T2 is 291 Kelvin. All right, so you notice in this problem then, what we are looking for is its new volume, V2. Notice that the pressure is changing, right? From 4, it decreases. And the temperature increased from 284 to 291. But it didn't say volume was constant. So there's too many things that's changing here. So you can't really use Boyle's law. You can't really use Charles' law. But you have to use a combination of those laws called the combined gas law. Okay, so V2 is our question mark there. All right, so where is V2 in here? It's right here. So we need to isolate this equation in order to get V2, right? So first off, if we want V2 by itself, we have to get rid of P2 and T2. I like to get rid of the bottom guy first, so I multiply both sides by T2. Right? If I do that, T2 goes away. Yay! Then I divide both sides by P2 to get rid of P2. Divide this side by P2 is multiplying it by 1 over P2. Review how to isolate equations if that is confusing for you. Okay, so P2 goes away. So your equation then is V2 is equal to T2 times P1 times V1 divided by P2 times T1. So notice both of these are on the bottom, so they stay in the bottom. All of these three are on the top, so they stay on top. Plugging things in here. What is our T2? T2 is 291. What is our P1? P1 is 4. V1 is 25. Divided by P2 is 1. And T1 is 285. Okay, cancel out Kelvin first. Atmospheres, atmosphere leaving us ml, which is a unit of volume, so that's good. You do that and you should get, okay, there's 3 sig figs, so our answer is 102 ml. Great. All right, Finally, let's do a checkpoint using combined gas law. Again, we're going to state out everything that we know, or is given to us. A weather balloon leaves the ground with a volume of 25 liters, so that's V1. At 25 degrees Celsius, so that's T1. Okay, 25 degrees Celsius is 298 Kelvin. And at 785 torr, so we're going to keep pressure at 785 torr, because if we have the other pressure in torr, it doesn't matter what pressure we use. What is the pressure of the gas? Where am I? Okay, it rises until the volume is 70, so that's our V2. And 225 torr. There we go. Our P2 is 225 torr. They're both torr, so I can keep them as torrs. So what is the temperature? T2 is what we're looking for. So again, using the combined gas law, which states P1 V1 over T1 is equal to P2 T V2 over T2, right? But we're looking for T2, so I like to use the inverse of this. So I flip everything. So if you flip everything, it becomes T1 over P1 V1 is equal to T2 over P2 V2. You see how this is a flip of this, and this is a flip of this? Okay, so that's legit. You can do that in math if you flip the whole thing. Okay, so I'm going to delete this now. So that's our new equation. But again, we're solving for T2, so we want to isolate T2. How do we isolate T2? We have to multiply both sides by P2V2, right? P2V2, because P2V2 will cancel out with P2V2, giving us our equation for T2, which is P2V2T1 divided by P1V1. Okay, so let's rewrite that. So T2 then equals to P2, which is 225 torrs, times V2, which is 70 liters. Notice I put a point there to let me know that that zero is significant, times T1, which is 298. I remind you to always keep your units in these equations so that you know that you're going on the right path, because they can cancel out. P1 is 785. V1 is 25. Liters. All right, let's cancel things out. Torr. Liters, Kelvin. Temperature is indeed Kelvin. Okay, you do that and you get that it becomes 240 K. But that's not an option, right? Because your answer are all in Celsius. So how do we get from Kelvin to Celsius? Simply the reverse, which is to minus 273, correct? Which becomes negative 34 degrees Celsius. Our answer there is letter C. All right.